What are the postulates of Bohr's model of hydrogen atom? Discuss the importance of this model to explain various series of line spectra in hydrogen atom. Okay, now first we are discussing the postulates. First, postulates. Okay, postulates of Bohr's atomic model. First postulate is orbit. Okay, now what is the orbit? Okay, now this is the orbit. Okay, this is the orbit. And what is orbit? Orbit is the electron in the hydrogen atom. This is the electron in the hydrogen atom, revolving electron in the hydrogen atom, revolving around the nucleus, in a circular path with a fixed radius. Okay, with a fixed radius, and energy is called orbit or stationary states. The electron present in the nucleus. Okay, the electron in the hydrogen atom can move around the nucleus in a circular path with a fixed radius, and energy is called orbit or stationary states. These orbits are numbered as, okay, this is the electron, and this is the nucleus, and this is the electron revolving around the nucleus. This is the nucleus, and the electron revolving around the nucleus. This is the orbit or stationary orbit. These orbits are numbered as. These orbits are numbered as. These orbits are numbered as 1, 2, and 3, and up to so on. Okay, these orbits are numbered as 1, 2, 3, up to so on. These are known as principal quantum number. These numbers are, these 1, 2, 3, 4 numbers are known as principal quantum numbers. Principal quantum numbers. And the next second one is energy of electron. Energy of electron in the orbit. And the energy of electron in the orbit, this is the nucleus, and the electron is revolving around the nucleus. This is the orbit, and the orbit which has the energy, which has the energy, and this energy of electron. Okay, the electron which is having the energy, energy, and the energy of electron in the orbit, the first, the electron which is absorbing the energy, and jumps from the lower energy. These are the lower energies and higher energies, and these are the lower energies to higher energy. This is the first energy level. Okay, this is the first energy level, and this is the second, and next third energy level, and next fourth, and next fifth energy level. The electron which is in the first, the ground state energy level or first energy level, which is absorbing the energy, and the electron which is present in the ground state or first energy level, and it absorbing the energy, and it will goes from the lower energy level to higher energy level, or lower orbit to higher energy orbit. At higher energy orbit, in this electron is absorbing the energy, it will goes from the lower energy level to higher energy level, and electron is present in the higher energy level. It is unstable. Okay, the electron, at higher orbit energy is more, but the electron stability is less. Okay, less stability. Okay, less stability, and this electron due to the less stability, it will jumps from the higher energy level to lower energy level, the electron jumps from the higher energy level to lower energy level and emits the radiation in the form of photon. The electron present in the higher energy level, it emits the energy. It jumps from the higher energy level to lower energy level. It emits the energy in the form of photons. This photonic transition causes the line spectra. Okay, now this is the energy of electron in the orbit. And the next third one is frequency of radiation. And the energy, the electron present in the lower energy level. The energy is E1 and it is excited from the lower energy level to higher energy level, and energy is E2, and the electron is present in the second energy level. It will fall back to the higher energy level to lower energy level. The difference between these two energy levels, E1 and E2, the difference between these two energy levels, which is indicated by delta E. Delta E is equals to what? E2 minus E1. E2 minus E1 is equals to h nu. So the change in energy delta E is equals to E2 minus E1 is equals to h nu. And next where h is equals to Planck's constant and next nu is equals to frequency. Next one is the frequency of radiation. This frequency of radiation, this is the nu is the frequency of radiation, and frequency of radiation is equals to delta E, and h is multiplication with the frequency of radiation, and which is taken from this side to this side, and nu is equals to delta E by delta h. And next E2 minus E1, delta E is equals to what? E2 minus E1 by h, and hence the frequency of radiation is equals to nu is equals to delta E by h is equals to E2 minus E1 by h. Next, fourth postulate is angular momentum of electron. Angular momentum of the electron. The angular momentum of the moving electron is quantized to the electron. This is the center of the nucleus, and the electron is revolving around the nucleus. So it exhibits the angular momentum. Angular momentum, which is quantized to h by 2 pi. Okay, which is quantized to h by 2 pi. And next, therefore, MVR is equals to what? NH by 2 pi. If n circles are there, that is n orbits, so the MVR is equals to NH by 2 pi. And the where m is equals to mass of electron, and next to v is equals to velocity, and next to r is equals to this r is equals to radius of orbit, and next to h is equals to Planck's constant, and where n is equals to this n is equals to what? Simple integer 1 2 3 up to so on. Next one is hydrogen spectrum. Bohr's explanation hydrogen spectrum. Okay, Bohr's explanation of hydrogen spectrum. When electric discharge is passed through gaseous hydrogen atom. When electric discharge is passed through the gaseous hydrogen, the electron in various hydrogen atom absorbs. Here this is the hydrogen atom, and the hydrogen atom, when electric discharge is passed through the this electric discharge is passed through this hydrogen atom, in a gaseous hydrogen atom, the electrons they present in this electron present in this gaseous hydrogen atom is absorbing the various amount of energies, absorbing various amount of energies, absorbing various amount of energies. They enter into higher energy orbits. The electron is absorbing the energy, the electron is absorbing the energy, it will jumps from the lower energy level to higher energy level, to higher energy level, and the electron is present in the higher energy level, it will fall back to the lower energy level, it will fall back to the lower energy level or lower orbit. And this happens in this electron is present in the higher energy level, it will happen in directly one step or in several steps. The electron is jumps from the higher energy level to this step, or in this step, or in the several steps, okay, or in the several steps, okay. Now this will takes the, okay, this will happens in the several steps. The electron jumps from the higher energy level to the ground state energy level, it will happens in the one step or in several steps, or multiple steps, and it appears in the form of line spectra in hydrogen atom. Okay, this electron is jumps from the higher energy level to directly lower energy level, or it will directly from the higher energy level to lower energy level, and it will leads to the formation of line spectra. Okay, now this is the line spectra, it will happens the line spectra, and the transmission of line spectra, the electron jumps from the electrons are jumps from the higher energy level to directly the first energy level, n is equals to 1. Okay, this is equals to n is equals to 1, n is equals to 1 energy level. This is also the electron present in the higher energy level, and this is also electron present in the higher energy level, and jumps from the higher energy level to directly n is equals to 1 orbit 2 in UV region. In UV region is called Lyman series. Okay, Lyman series. And the next one is the electron jumps from the higher energy level to n is equals to 2 energy level. Okay, this is equals to n is equals to 2. Again, electron jumps from the higher energy level to n is equals to 2 energy level in visible region. In visible region is called Bohrs series. And next, the electron is jumps from the higher energy level to n is equals to 3 orbit 2 in near IR region. In near IR region. This is in near IR region is called Passion series. Okay, Passion series. And the transition of energy of electron from higher energy level to n is equals to 4 energy level. N is equal to 4 orbit. Higher energy level to n is equals to 4 orbit. n is equals to 4 rb2 is called in middle IR region. In middle IR region is called bracket series. Bracket series. And transmission from the electron jumps from the higher energy level to higher energy level to n is equals to 5 energy level. N is equals to 5 energy level. N is equals to 5 energy level in far IR region is called fund series. Is called fund series. And the electron jumps from the this is the diagram from the for the line spectra of hydrogen atom, and the gap between the first energy level and the second energy level is more. This is the gap between first energy level and the second energy level is more, and this is the electron jumps from the higher energy level to n is equals to 1 energy level in UV light or UV region is called Lyman series, and the electron jumps from the higher energy level to n is equals to 2 energy level in Bohrs series. Okay, Bohrs series is in visible region, and the electron jumps from the higher energy level to lower energy level. That is the Passion series in near IR region, higher energy level to n is equals to 4 energy level in middle IR region bracket series, and higher energy level to lower energy level in far IR region is called fund series. And we can calculate the formula to find out the wave numbers. And nu bar is equals to wave number. Nu bar is equals to wave number, and wavelength is lambda. Okay, nu bar is equals to what? Nu bar is equals to 1 by lambda. That is equals to RH into 1 by n1 square minus 1 by n2 square. RH is the Rydberg constant. Okay, RH is the Rydberg constant. Okay, this is the very important question, and subscribe my channel and click on bell button for the further notifications.